we're going, okay, it's recording now. So this is 2 of the problems from the old exam, in case I don't have time to make a video on Monday for you guys. So, and then I will post this online so you guys can do it. Okay. So this is number 9 on it. We have f of x, y equal to x squared plus 2y squared minus y, 4, closed region. So we have to find f max and f min for R, and here's the graph. And they give you this. Sometimes they might not. Just remember. For the region R. So remember, yeah, sometimes they might not give you a graph. Yeah, the one that you said, like all the ones. This time they tell you, but I'm just saying they might not.
How is that the same thing as the equation different?
That doesn't need to be the same thing. Like if they, so imagine like a 3D thing. So the function is equal to z, and then it's like coming out of the page and you're trying to find the maximums. Because the function is a function of x and y, right? So we can pretend it's equal to z and say the z coordinate z or whatever x's comes out of the board. So then the max would be like a hill coming out, the min would go inside the board or something like that. Okay?
So when would we need to draw it?
If they just give you this, and this would be y is equal to 0.
That's a x squared plus 2y squared.
Right here?
No,
yeah, up there it's x squared plus 2y squared. So if they gave you just these 3, you should be able to draw that.
The boundaries?
Yeah.
And they'll give you the equations for the boundaries.
Yeah. Most likely they'll draw it for you, but like from now on, you're expected to draw it sort of as well. Because once you do 3D things, you have to figure out how they look and stuff. So like if you are given x squared plus y squared equal to 1, right? It's a circle, but it's it intercepts this line right here, and y equal to 0 is the lower boundary, something like that. Okay, so for part A, we have to look at the interior candidates. X comma y and so we have to find the x, y values and what the function is equal to. What do we do for interior values? Do you guys remember?
Do we take the partial of x, partial of y is equal to 0?
Yep. So we have the partial of x.
I mean, you weren't wrong.
I didn't hear you actually.
I said test them.
Okay.
We have
He's
nothing
like,
to
just
test.
It's like disappointment.
So there, it's all in Dino slides as well. They write down the short form of all of this. But you find f of x, which is what in this case? 2x. We set it equal to 0. X is equal to 0 now. Can you guys read that?
Yeah.
F of y is equal to what? 4y minus 1. We set it equal to 0. And y is equal to what? Positive 1/4. So then the function of 0, comma 1/4 is equal to 0 squared plus 2 squared, which is 1/16. 4. So this is,
Okay, so you just take that point and plug it in.
you take the x and y points and you plug them into the function.
Oh, they gave us gross fractions.
But this is 1/8 minus 1/4, so it's negative 1/8. And that's equal to f of 0, comma 1/4. So that's our first point. So that's like a point going into the board, essentially.
We don't have to.
You do need to
Not the
understand
only
this, like,
interior-
I don't want to know it.
because once you get to the later units, maybe even the next unit, you will need to understand all of that stuff, like imagining in 3D and stuff.
What does that mean? It's going into the pool.
So imagine it's like a cloth.
A clock.
Like, okay, I'm gonna try to explain this. So you see this cloth right here, right?
Kinda, sure.
Right there. Okay, that picture is just the flat surface that it makes on the table. Okay, but it's coming up and down and all of that, and the curvature of the cloth is our function. So the max would be like this point up here. Going into the table, that'd be a min or something. So it's like something 3D pushed flat, like this bottle. Like if you were to put it in an XY plane, you might have a circle, right? But it's maxed up here if you have the function, right? And then if our
So then the point-
plane was through here, this would be the min, that would be the max.
You said it's into the board, but what if like Z? I mean, doesn't that just depend on where you put your positive and negative axes?
Yeah.
We didn't mark it.
Yeah, but normally it's used like a right-hand rule thing, where Z positive would come like that, X and Y.
We're not hurting anything.
No, but the
There's nothing being crossed.
the direction of Z is determined by which one your X and Y value. I mean, which axis is X and which axis is Y.
There's no vectors being crossed here, sir. This is a.
So it's going into the board.
How is it going
negative.
to?
If your X is on the right side, positive, going this way, Y is going positive up, Z positive would be coming out.
So then this point.
That's a convention. But yeah.
Oh.
This point is 0, 1/4, negative 1/8.
Yes.
Yeah.
And
If we were-
that's just one of the maximums or minimums.
Yeah. It could.
It's a critical one.
Yeah. It could be the. So we're looking for.
Local max.
Yeah, it's a local max. We're looking for the.
Why did we decide?
best.
How do we know it's a max and not?
We don't know that. We don't know any of that yet.
Okay.
We need to test the other points. Okay.
Okay.
Does that all make sense?
Keep going.
Yes.
Captain. Keep going.
And the people watching the video sort of missed the analogy.
Oh, because you're just like a cloth.
Yeah.
Yeah.
But it does make sense, like that explanation. So B, we are testing now the boundary points.
Boundary.
So our first equation, we're going to test is y equal to 0. Okay? So if y is equal to 0 and we have the equation, we have the function, right? At this line, the function would have y at equal to 0, so it'd be f of x comma 0. Does that make sense? Because it's like
Y is always 0.
at the edge, so the function would have it 0. At the boundary.
So it's x squared.
Yep. X squared. And we have our endpoints according to the graph, -1 less than or equal to x less than or equal to 1.
But that we had to determine on our own.
This,
Yeah.
if you weren't doing the graphs,
But
Will it ask for that?
you need to know the endpoints because you do need to test them as well. You need to, so there's 3 things that you need to do. You need to set the derivative of this df dx equal to 0. Okay. You need to test the undefined points and the endpoints. Like those are the 3 parts that you guys should know. Okay. So first we set the derivative of it equal to 0. Therefore, x squared equal to 0. Therefore, x is equal to 0. Right? So now we have 1 point, 0 comma 0. Okay.
Yeah, why isn't it 2x?
Well, it's gonna be 0.
Oh.
Yeah, I solved for x. Right there.
So
what? It isn't 2x?
it is 2x, but it plugged in 0.
Like, hold on.
2x is g.
I set the, it should be,
Yeah,
2x
it's
equals
2x.
0.
they wrote it wrong.
I still haven't checked those times this morning.
But yeah, good catch, guys. So it's the derivative with respect to x. 2x is equal to 0, x is equal to 0. So we have our points 0 comma 0. So then the function 0 comma 0 equal to 0. Okay. Now we have another point that could be a max or a min. Okay. The second thing that you should test is undefined. But that's not going to be undefined, right? The function, what do you call it? X squared. That's not going to be undefined, right? So then we're going to ignore that. So the next thing we'll test for is endpoint.
Is that, we don't have to do,
We don't have to test for where this is undefined because
but we don't have to test for y equals x plus 1.
we're going to get there. We have to test each boundary. So this is just testing y equal to 0. So the endpoints that we have are x is equal to -1 and x is equal to a 1. So then if we plug them in, we have the function of -1 comma 0 and the function of 1 comma 0. But if we plug them all in here, we get 1 and 1. Right? So then we get 2 more points, or coordinate points.
Do we do this with every single
Boundary.
But they like walk us through it, right?
Yeah.
Okay.
They'll tell you like part I, y equal to 0. You know, I, y is equal to x plus 1. So they guide you in that sense.
So what's f of -1, 0?
So I'm going to write them over there actually. Do you have a question?
What's f of -1, 0?
F of -1, 0, 1.
It doesn't look like we're gonna do the ones. You like erase it so it pops.
Oh, that's very close. Are you guys happy?
Yes.
Okay. So the 2 points, or the 3 points okay right now. now we have along
Daniel, is 0, 0 also have a point?
We did it.
0,
We
0.
said f of x
Oh yeah,
equals zero.
I forgot to write that over here.
What did, oh, we wrote it up there. Oh, we dropped it.
So you have to keep track of all the points that you find, essentially. So along y equal to x plus 1, that means the function is x comma x plus 1. So now you have to solve it. Plus 2 times x plus 1 squared minus x plus 1. Because we substituted wherever there's a y for that. Therefore, we have, so this is 2 times x squared plus 2x plus 1. So that's 2x squared plus 4x plus 2 minus x minus 1. And then we have an x squared here. So that's equal to 3x squared plus 3x plus 1.
You set all of these equal to 0 when you solve for the.
So that's first part, d of dx equal to 0. And it's between what points? So what are the endpoints for that?
What?
The endpoints?
Are we
Negative 1.
setting it equal to 0 right now?
Yeah, but they still want us to mention the endpoints.
Don't we do that later?
Yeah.
Well, I forgot to mention it up here. But it's negative 1. I forgot to mention it up here, but you do need to write the endpoints there. Or you need to show them. So like once you show your function, you need to show the endpoints. So okay. We set that equal to, okay. Sorry, I shouldn't have. I wrote that. What is the derivative equal to? 6x plus 3. Right. So then x is equal to what? Negative 1/2. Y is equal to positive 1/2 because we plug it in there.
Where do we plug it in? The y?
Along y equal to x plus
Okay.
1. So then we test that point. So we have, plug everything in there. They ignore the 3. Oh, sorry, my fault. We plug the points into the actual function. Yeah. Sorry, I said that wrong before. We plug the points, or it doesn't matter. We plug the points into the very top function. So we have 1/4 plus 2 times 1/4, so it's 1/2, minus 1/4. minus 1/2, sorry. So then we get 1/4. I think you can plug them into this function or the top function, but it's just easier to plug them into the top function. So you get 1/4 as your answer. Okay. So now what do we test?
Now we're getting it.
Endpoints. We have -1 and 0. So when x is equal to a -1, what is y equal to? 0. But we already found that point, so no need to do that. When x is equal to 0, what is y equal to? 1. So we plug in that into the function, or we can also plug in here. We get 1 as an answer, and that's our next point. So let me write that here. So, any questions on that? It's a fairly straightforward procedure. What? Because you've done finding maximums before.
Why don't we have one endpoint?
Because
Well, we do have the other endpoints, but we already found it. So we have -1, 0, but that's part I. Like we already found it in part I. Like we already tested for this in the first part, so we don't need to write it again.
You don't have a set Y.
not for this one.
Oh, they need to get a new.
Are you guys good with this part?
Yes.
Yeah. Again, make sure you don't lose track of the points, because one of them might be max or min, and you just forgot to write it. So now we have x squared plus y squared equal to 1, right? So what are our endpoints?
X and Y.
0 to 1. The best thing that we can do for this is to convert this in terms of, well, you could do it either in terms of x or y. They change it to in terms of y, or so x equals something. So if we were to do this, x is equal to, what would we have? Plus or minus the square root of 1 minus y squared. But is it a positive or a negative? Since we are on the top, this is a positive. The x-axis. Like this is on the top, so it's. So this is equal to x equal to the square root of 1 minus y squared. If we were under the curve, it'd be negative. So then our function is actually plus the square root of 1 minus y squared, comma y, equal to, now since we made it in terms of y, so we just plug it in for x, right? It's easier to just solve it that way. So what is the squared? 1 minus y squared plus 2y squared minus y. if we had found this y equal to, we would have needed to plug it in here and in here, right? So then our function would have a square root in it, and then it'd be a whole mess if we were to take the derivative of it and stuff. So what is that equal to? 1 minus y plus y squared.
Y squared minus y.
So now, since we do have an equation in terms of y, what are our endpoints?
Charles has a good question. You have it in terms of y, you need to change the domain to terms of y.
That's what I was asking right now.
Oh, Charles says yes.
Yes, you do.
Charles says yes.
So what would the endpoints be now?
0 to 1.
0 to 1. Good job. We don't need to worry about it now.
Okay.
I mean, these are equivalent, you know, if we had found it in terms of x or in terms of. So df dy now equal to 0. So what do we have? -1 plus 2y equal to 0. Therefore, y is equal to 1/2. Okay. But what is x equal to? We plug 1/2 into this equation. So we get, let's see, 1 minus 1/4. Yeah. So it's equal to the square root of 3 halves.
Why did you miss it?
So now we have our 2 points. We plug them into the function. We plug them into the function at the top. We get 3/4 plus 1/2. That is 2 times 1/2 squared minus 1/2. So we get 3/4. So that's one of our points. And then we test the endpoints. But if we were to test the endpoints, why should we not worry about this stuff?
Did you do all
Have
of
we
them?
already done that?
We already did all of them.
So, okay, so once you test all the endpoints once, you don't have to test them again, no matter what kind of value.
I mean, no, it's the same function. The values at that endpoints aren't going to change.
So you just have to do each one time.
You should get the same answer if we say y is equal to 0, x would be equal to 1. We plug them into the same function. We should get 1 right here.
It's gonna take up a whole page.
Well, most of the whole page, like from here to here. But we're almost done right now. So the next part, what is our min? What is the minimum value that we found? The most minimum? -1/8. And they ask you to write the coordinate, so 0, 1/4. And what is our max? Yep. Our max though is equal to 1, but it occurs at 3 points. 1, 0, -1, 0, and 0, 1. So this is like part 4. So this problem isn't actually a tough problem because you've already done stuff like this before in Calc 1. Just long, sort of. Um, are you guys good to move on?
Is all calculus partial derivatives?
And you have triple integrals then.
That's
Well,
right.
there's also summations and stuff.
What? I thought we were done with those.
Nope.
Summation.
Is that series?
With like series.
More series.
Like there's a lot of stuff in Calc.
More series.
And you have to memorize a lot too.
More series. You just want to see how many of us you can get.
Well, I have nowhere else to go, so they're stuck with me.
Yeah, I know. That's my attitude. Danger's my no go.
Who's gonna marry me?
Okay. For 10 we have a box.
Just want to lick it. I embrace your
I feel like I just don't like them. Yeah, I never thought about it until like someone was like, "Why are you talking about kids? Do you even like them?" And I was like, "Actually, no."
I definitely don't know.
All right, guys, let's get back to this.
Oh, okay.
So we have a closed box. The front and the back cost $2 per feet squared.
That would be awesome.
The top, bottom, and sides cost $1 per feet squared.
Did you say that? Yeah.
The volume is 54 feet cubed. So we have to find essentially at the end the most minimum cost, like what side lengths we can have to make the cost be the minimum. So it would still hold the same volume. So the part A is find cost in terms of length, width, and height.
Do we need cost, like mid cost?
The term cost,
Like
so-
just an equation?
so C is equal to, so if we just do the front and the back, we have $2, and that's equal to length times height, right? Times 2. So it costs $2, but it's 2 times length times height. So this is the front and back. Okay. The left and the right side cost $1, and that's 2 times the width times the height, and the top and the bottom, that's 2 times the length times the width. Okay. And if you were to simplify that, that's 4LH plus 2WH plus 2LW. Part B is find H in terms of length and width.
It's a
then cost in terms of length. Okay, how do we find height in terms of length and width?
You solve for B. You said 54 equals
Yes.
length times width times height.
54 is equal to LWH is equal to 54 LW. So our cost, we plug that in for height. We have 4 L times 54 LW. Yes, we substitute plus 2W times 54 over LW plus 2LW. So 4 times 54, 216 over W plus 108 over L plus 2L W. That sounds weird saying W.
You said W so many times, it's weird.
Yeah.
Yeah, I understand.
Do you guys get this stuff? So now we found cost in terms of length and width.
Do we start taking part B right now?
Yeah.
Okay. Is this still part B or is this still?
This is part B. Part C, we do it.
Wait,
Wait, after wasn't done. Thanks for asking. Consider others.
So how much can you teach in that?
Good. Wait, what time?
It's almost like,
Oh, it's almost 5. So you've got till 5:30 technically.
I know,
well,
but I have to
okay,
leave.
okay.
But,
Just keep
okay.
going.
I don't know how much it was. Even if it was one.
The partial derivative of C over L. And they guide you through this by asking you to find all of them. Okay.
Let's do Jenny's problem after this.
Oh, no.
Okay. Um,
Sorry.
Yeah, it's leave.
the cost over L is what? Taking the partial with respect to L, this would be 0. Taking the derivative of this and the derivative of that with respect to L. So that would be negative 108 over L squared plus 2W. Partial of C with respect to W is now negative 216 over W squared plus 2L. Make sense?
Yep.
The second partial derivative with respect to L squared would be the second derivative of that, and that would be 216 over L cubed. Make sense? This is L to the negative 2 power. We bring that down. Partial of C, second partial of C with respect to W squared. W squared is 2 times 216, so that's 432 over W cubed. And the next part, because this is a negative 2 exponent, so negative 2 times negative 1 makes it positive. Where do I have negative?
Oh, sorry. I was looking for.
Okay. That's okay. And the partial squared of C with respect to W and L. So which one do we do first?
The L.
And then we go to W. So we found the L. That's the with respect to L. So the partial of that with W is, did you say? Or
We did say,
Oh, sorry.
Alright, what would it be?
Two.
it'd be 2.
It'd be 2.
Yep.
Wait, is that an L? It looks like a C.
You're righty.
There's no- I was like, oh.
I'm sure you guys.
Oh, that's a. They're the same. Yeah, but my L is cursive. Yeah.
Okay, so part D, we have to find C min with L, W, and H.
This
You
is
laughed.
he totally didn't
You
handle
laughed.
it.
I was not gonna laugh until you said
Okay.
it.
What do you laugh at?
What did you do?
What happened?
Well, ignore that.
I was not.
Okay. Well, I realized that I said it, so then I was like, because it is recording, but okay.
Well, Jordan said circumcised instead of circumscribed.
Okay,
You were there.
guys, quickly. Yes,
Okay.
leave the.
Okay, so is this where you do negative 108 over L squared plus 2W times negative 216 over W squared plus 2L?
We have to first
I
set.
will hire you now.
We have to set these equal to 0. Is that what you're saying?
No, that was not what I was
Is
saying.
it
Okay.
just that formula you plug it in?
Yeah, I thought you plugged it into
What's the
like
question?
We have to find.
the min. Actually, I don't know how to do that.
So the process is we're gonna go through the process, but we do plug it in into the original formula. So,
The f of x or just do it.
Just do
okay,
it.
we'll just do it. Okay. So partial of C with respect to L equal to 0. So we have to find, just like finding the min and max. So negative 108 over L squared plus 2W equal to 0. So we get 2W L squared equal to 108.
Okay.
And you'll see why we're doing that. We set partial of C with respect to W equal to 0. So negative 216 over W squared plus 2L equal to 0. We get W squared L equal to 108.
Does the problem tell you like specifically to take the partial of L with respect to W?
Yeah. The reason we're doing this is that so we can find W in terms of L or L in terms of W right now. Okay? So if we were to subtract these two, we would get 2W L squared minus W squared L equal to 0. Okay? So now we have an equation of L and W in terms of each other. So let's factor, or what?
Do now.
So both of them have a WL,
Yeah.
so we can. Are you guys good here? So the idea is to find W and L values. So we have 2WL squared minus W squared L equal to 0. So we take out a WL, we have 2L minus a W equal to 0 here.
Oh, no, they need to.
So W now is equal to 2L. Okay? Makes sense?
Yeah. So then you plug right in.
We also know that, where's the volume? They plug it in back into the volume equation actually.
Okay.
Volume is equal to 54, which is 54 is equal to length times width times height, right? Height is equal to, wait,
Height is equal to
no, that would not make sense what they did.
54
I am forgetting something.
So then, so then we can 2L squared. It's 54 over 2L squared. 6 over L squared. 2L H.
Wait, would be,
So L cancels.
I'm just gonna, yeah, I'm gonna try this, but it shouldn't work actually.
It shouldn't work.
Does this, I don't think they put it into this. I'm forgetting an equation. They have L times L squared, which is the width, and they set it equal to 54.
Oh, did they plug it into the cost equation?
Oh. That's
That might be it.
bizarre. The cost equation.
We have it in terms of,
is-
That can't.
no,
There's
why
a
is
lot
it
of
equal
stuff
to,
in the cost equation. It's more than 2L.
oh, wait, hold on, sorry. Yeah, sorry. It's pretty simple.
I'll take your word.
Here we go.
Oh.
We can plug it in here, or we can plug it in here. So one of these. So if we do both of them equal to 54, so we have 2WL squared equal to 108. W is 2L times L squared equal to 54. So then L cubed is equal to a 27. Therefore, L is equal to 3C. And that's how you find W by, so it's 2 times that, right? That's how you find W 2 times L.
L, the other two.
And height is just, we found height formula.
Just kidding.
So do you get how we find L, W, and height? No?
And then you plug it in.
We got this equation from when we set them equal to 0. We got this equation, right?
Okay.
By setting them equal to each other, we found W is equal to 2L.
Yeah.
By plugging in W right here, we get the value for L.
And then you plug it back into the volume.
Yeah, well, for W, we just plug in 3 here,
Yeah.
and we get W is equal to 6. For height, we plug it into the volume,
Yeah. That's
and we get that.
okay. That makes sense.
So that's the main part. And then to justify it, there's a
That's
formula.
not enough justification.
We have to justify that it's the minimum, not the maximum. And that's the equation. Let me write it for you.
Oh, that's weird.
I'm going to write it here for you, but it's in Dyna. It's the CLL times CWW minus CLW squared.
It's the same thing.
And then whether it's greater than 0 or yada yada. We'll get to that, but that's how we find L here.
Yeah, it's.
W is equal to 2 times 3, so that's a 6. Height is equal to 54 divided by LW, so it's 6 times a 3, which turns out to be a 3. So that should be that. Have you guys, do you have any questions till this point?
Why does partial C over L and the C over W, what is that doing? Like, that's just random.
So in Dino, on the first day they taught this, they go through this. You know, the process of finding a saddle point, whether it's less than 0 or greater than 0, that sort of a thing. They go through that. So it's just that stuff applied in a real problem.
But you're not using that formula.
What formula?
The CLL CWW minus CL.
Yeah, you use that to test it.
Yeah. So we're using that to see if we actually found a min or not.
Oh.
So we plug in, so you know how we found L, double L, we found LW before, we found all these values? We'll just plug them in there this time, and if it's less than 0 or something, it's good. No, they need to be greater than 0. Does that make sense?
Positive
Yeah.
to
Have a good weekend. Yeah.
See ya.
positive to min.
If they're both greater than 0, then it's the min, and I'll show you guys. We'll do it right now. So let me, are you guys good with this right now? Yeah. Oh, we didn't get to her problem.
No, she's gone. Do this problem and then I would.
Here, as long as you're doing that.
Do you have any questions? No? Do you understand what? Okay.
It's just a process that like students take you through.
So the equation is CLL at the point 3 comma 6, because we found length and width, and we found everything in terms of that, times CWW at 3 comma 6 minus CLW squared at 3 comma 6.
And the equation is to test those.
Did they give us this equation?
Are we, what?
Did they give us this?
Yeah. Are you saying the points?
Yeah.
Yeah, we plug those points. So they gave it to you in here, but in general, you should know it. So they'll probably give it to you, but as always, you should always know it. Because you might have a problem that's not a box problem, but a general problem that you have to find the min and max and show whether it's a saddle point or not. For that, they might not give it to you. Okay? So we did find our CLL and all of that. So our CLL was 216 over L cubed. So now it's 216 over 27. It's not up here, but you guys wrote it down. CWW was 432 over W squared. So now it's 432. W is 6 cubed, so that's 216. Yep. Minus CLW was just 2, so it's 2 squared. So you don't actually need to solve it, but just by looking at it, you know it's greater than 0, right? Just by looking at it, you know it's greater than 0. And the second part that you need to test is CLL, just that at 3 comma 6. And that was this right here, this part, 216 over 27. And we know that's greater than 0 just by looking at it, essentially. Since both of them are greater than 0, we have a min. I think this is how it went. If this was less than 0, then we have a max. If this is equal to 0, it's the saddle point. And then there was one more where the test fails. Let me find those on here quickly for you. You have a question?
What is that equation? CLL 36. Like, what is that doing?
That essentially they told you that equation. I'm sure they derive it in the notes. Trying to find it again. That helps us know whether it's a max or a min or a saddle point. Okay, so this is how it goes. So it's in Dino, it's a second derivative test, but essentially you just need to know that this formula tells you whether it's a max or a min. If this is greater than 0 and this is greater than 0, it's a min. If this is greater than 0 and this is less than a 0, it's a max. So you need to have that memorized. If this part, all of this is less than a 0, then it's a saddle point. And if it's equal to a 0, the test fails. So that's how it's in Dino. And that is something you need to
is this a
memorize.
under objective 9? Is that what it is? Is it like that problem?
I'm not sure what objective, because my,
Okay.
it's tangent line to curve of intersection of two surfaces. That's the objective.
Okay. Yeah.
because these are my notes and they might have switched things around a bit for you guys. But essentially, that's how we know it's min. So don't count on it being a min all the time. If it is a max, I think you just a max. No, I think it will be a min all the time, actually. Because the way they word the question, justify you have a min and not a max. So it's like, and then part D is values for the minimum. So I think you will get a minimum all the time. So any questions on this entire problem? So these are really long problems. But I do think though, besides for like this part that we right here that we found length and width, most of these are straightforward, right? So don't expect on being good numbers. It might as well be like 3 cubed root of 3 or something like that. So don't count on it being easy numbers. And if it is something with cubed root 3, you just go with it. Right.
Do we have to find it in terms of W and L, like we did, or just like as long as we just two variables?
They'll tell you W and L. I think they tell you on this W and L, and every problem I've done is W and L, but you could do it with any way. You know. I'm gonna say that is it, and then I will put the rest of this. I'll put the exam online with the answers. If I have time on Monday, I'll go through them on like a video because I am not allowed to put up solutions without going through them. And then there's other stuff though that you guys do need to know, like the formula for linearization, because I believe people just forget to study that. I'll write it up here too. So the other parts are linearization. There's the whole section on accuracy, you know, error and stuff. With the relative error, percent error, that's also part of this unit. And then there's the problem with the finding the unit vector and the direction of it, sort of thing. And I think this was on video. I'm not sure.